everyone. I hope you can hear me. Um, if you have any questions or suggestions, feel free to drop them on the Slack channel or on the comment section of YouTube or also on Slido. The instructions have been sent to your email. If you think, please feel free at any point in time to let me know your thoughts. This is going to be streamed live on is happening live on YouTube right now. So once again, my name is Joseph Itopa Abubakar, and I'm the one taking you for the Q1 cohort end-to-end ML project. So before we begin, we are going to make you understand how you can start with the project. The first thing is for you to go to the EagleSense GitHub repo, and then the branch Q1. That's the branch that you will be working on. So you just copy the link to the EagleSense repo. You can see under the repo we have folders for notebooks, for presentation slide. Under this folder presentation called presentation slide, you will find the assignment and the slide to previous to last week's recording. So you copy this link. I'm going to use my account as a demo. This is EagleSense GitHub account. You copy this link. You go to your own. Enter it on your browser where you are logged in as a user. This is my personal account. So you logged in, and then you can see this is the EagleSense repo that I'm viewing. So the best thing you can do now is to fork it. You fork it, that means you now have the version of EagleSense repo on your own under your own account that you can work with. So you fork it. Okay. So also don't forget to star the repo. You have to star it, but then that's before you fork. Like here we have you see it's now under my account, Joseph Itopa end-to-end ML. So I have cloned, I've forked the repo, so I now have a version of EagleSense repo under my account. So after this, you then go ahead and clone. So you clone using this SSH, you clone. So the description on how you should go about this particular stage is in the assignment section under this presentation slide here. So it's under assignment 2, under the document or inside the document assignment 2, you find the description on how you should clone your GitHub repo, and of course you may face some challenges what you should do about it. So before we leave here, do not forget that you are supposed to star EagleSense repo. So you just click on this star here, and that's all that is needed. Star it and fork it. So first you star it, then second you fork it. So that's all for the GitHub aspect of this. I won't have to clone this because I have already cloned my own, and it's here. We can see it here. Yeah. So this is the folder that was cloned. This is the presentation slides, and this is the notebooks that we are working with. So initially I was thinking we should have a separate notebook, one for the session and the other one for the assignment, but then we are not going to be doing that anymore. So what we'll be doing now is that the notebook I used to prepare the class, inside the notebooks I'll keep cells that will contain the assignments you should do. So when we go through this, I will quickly guide you through what I'm talking about. So I think that will be all for GitHub. So let's go into the main class. Please, if you have assignment questions or suggestions, paste on Slack, and also feel free to paste on GitHub, on YouTube rather. So I'm going to go to YouTube, YouTube Live, and of course we are currently live, and yeah. So you can drop your comment here while I continue with what I'm working on. So back to the session. In this case, we'll be working on our data sets. That's where I cloned it, but this is the data set here. So the first thing you need to do is to go to your terminal, though I'm using Linux environment. So if you're using Jupyter, you just go to Jupyter, then you type lab. It will open the environment for you. If you're also using Anaconda, it's the same thing. All you have to do is navigate to the particular folder where the files and notebooks are. So we have started already. For those still asking when are we starting, so while we continue, I will also try to encourage every one of you that if you have any issue, email me, email the ask at eaglesenseai.com, email it, or you email the eaglesense.ai@gmail.com. You can also email that. So to go and begin our work for today, we type Jupyter lab. So once we hit this, okay, this is not the browser I used to access. Jupyter works with mine works with Chrome. So I'll go ahead and hit this. Okay, for those having issue with getting wait notification, I think it may be a network, because I am currently streaming live, and everything seems to be fine from my end. So the first thing we do is to load the libraries. So we load these libraries. Load these libraries, then so the other thing we need to take into consideration is that we have to bring up some of the basic libraries we be using, though not all of them, because there are other ones we'll be using later on. So in this case, we import pandas, numpy, seaborn, matplotlib, and then we set the size of our figures when we display them, and then the axis and the background color. So when we do this, we run it, and it's fine. So we get our data set from GitHub. The name of the data set is Bankful dataset. It's all about whether particular client will subscribe or not subscribe. The description of the features of this data set is below. We'll still talk about it. So we load the data set from GitHub, and then we try to display the top 5 and take a look at them. And then we see the shape of the data set. We see that we have over 45,000 rows, 17 columns, and then we try to get summary information about this data set. So when we do this, what we get is that they are all 45,000, over 45,000 rows. None of them is missing, but we'll further confirm that later. And then we see that age is integer, job, marital, education, all these are string, otherwise regarded as object. They are strings. And so overall we have 7 integers and 10 string features. And then in total we have 17 columns and 45,000, over 45,000 rows. So we also check to see, using this, to see if we have any missing feature. We don't have any. None is displayed to us. So we check for duplicates. It's very important, because what we are going to be feeding our machine learning models are not duplicates, but rather a specific instance of occurrence in time. That is what we are building weight around. So if we use duplicates, there's tendency that our machine learning model will be biased, and it will start favoring some features over the other. So we don't have duplicates. We checked for duplicates, none is present. So we decide to now go further. And then check for outliers. Are they present? So, and when we run it, we first check outlier for the feature age. When we do this, the thing with outlier is that it has lower quartile, then the median, then the upper quartile. So anything above this upper quartile to the right is an outlier. Then anything below this lower quartile to the left is also an outlier. But in this case, we have outliers on the right. So there are several ways of removing outlier, but in our case, all we just have to do is filter off 70. So all the ages that are 70 and above, we regard them as outliers from here and above. So we filter them off, and then we check what is left using the dot shape. We check what is left with our data set. So from over 45,000, we are now having over 44,000 rows. So we check again to ensure that we have removed the outliers on age features. So we can see that they are no longer there. So age is fine. We move further below to see the description of the data set we had. We have the age, which is numeric, the age of the clients. We have the type of job they are into. Are they self-employed, blue collar, are they managers or entrepreneurs, stuff like that. So then we also have to consider their marital status. Are they single, divorced, married, or unknown? Then their education, is it basic, is it high school, professional, university degree, is also there. The default has credit in default. Have they defaulted in the credit they are owing or not? Then are they also having house loan presently? And then are they engaged in personal loan that they are also involved with? Then the contact, do we have their contact, phone numbers, telephone, cellular, or we don't have any, which is unknown. Then the month of the year, so we have to know the month at which these subscribers these subscribers subscribe to this. So the next thing we have to consider is the duration, the last contact duration. So this is more of like it's in seconds, yeah. So, and according to the documentation, this attribute highly affects the output of the target. So we have to put it into consideration. But then that's not enough. We still have to do feature selection by next week to be certain that it's important. So we consider the month, we consider the duration, then we consider also the campaign, number of contacts performed during this campaign, and it's also numeric. Then the P days, number of days that pass by after the client has last contacted was last contacted from previous campaign. That's from the previous advertisement campaign. So we also consider the previous number of contacts performed before this campaign. We have the data. Then we have the P outcome, which is the outcome of previous marketing campaign. Then the last but not the least, which is important to our data set, is the Y. Has the client subscribed a term deposit or not? So what we are working on is a binary classification problem. So next week, before we start talking about how we go into training algorithms, we'll first go into what is binary classification, what the theoretical part of binary classification. We'll take a look at it before we start applying it to this data set. So our case here is to try to predict if a client will subscribe to term deposit or not. So after all the campaigns, after getting the data about the job description, the marital status, and other things, we will now go ahead and put all this data together to predict will this client subscribe to our term deposit or not. So that's basically the description. If you want to, by the time you clone the repo, you will get more idea on what it is. So we check the columns again, what we had. This is what we have available, and then we check the unique features of those categorical the unique parameters of those categorical features. So we do that with contact feature, because there's a column called contact. I think yeah, this is it. This is contact here. So we see that under contact we have unknown, cellular, and telephone. And from our description, the documentation only says cellular and telephone. So this one that wasn't, since we were unable to get it from the client whether it's cellular or telephone, we put on they kind of document it as unknown. Then we also we do a value count on the contact, which we just look at the parameters of the column. We do a value count. We see that cellular is like made up of over 28,000 rows of the data set, and unknown follow up. So in this case we can't say because it's unknown we have to drop the unknown. Unknown play a very huge role, so we have to leave it there. And telephone is like over 2,500. So we do the same for the P outcome, and we see that we have unknown as well. We have failure, we have order, we have success as the unique parameters of that column. So we also try and do a value count on them. We do a value count, and then we see that unknown play a huge role. They didn't collect data from most of them. They couldn't get the data from the client, so we have to leave it that way. We can't remove it. It's important. So your exercise 1, you print out the unique features of y and then do a value count on it. So the first cell is for you to print out the unique parameters of the feature rather. Then the second cell, you are going to print out you are going to do a value count on those parameters and see how they are distributed in the data set. So then the other one is to also, exercise 2 is to do the same for parameter, what we've just done above here, for marital status. So you check the how the parameters for marital status, the unique parameters, married, divorce, you print them out, and then you also do a value count on them to see how they are distributed in the data set. So after that, okay, we continue with job. We can see that we have different categories under job, many of them. I think they should be up to 10 or so. So we do a value count for job, and what we have here, okay, blue collar seems to top the list, followed by management, and then technicians, and so on and so forth. Unknown made a very low number here. So in this case, you may say you want to drop unknown, but it's too early to decide. So for you to consider dropping unknown in a situation like this, you now want to check, is there a situation where job is unknown and then job is unknown, contact is unknown, and which other one had so many unknown just now? P outcome, I think. Yeah. So any row that has all of these features to be unknown, you can drop them before start training algorithm. So to those facing sound challenges, I am very certain is the network problem in Nigeria, because we've resolved most of the issues, but no worries, maybe after this live recording you can still watch it again. Hopefully you shouldn't have that issue, maybe because it's live, that's why you're having the issue. Then we go ahead and print this just to see the data set again. So we decide to do some visualization. So the first thing we do, we select some features we want to see how they correlate. We select job, marital status, education, default. Then we group it by marital and default. Then we do a count using the default. So when we do this, run this, so we see that married people, those that did not default, we have over 26,000, and married people, those that default, it's like 400. So all of this, we put it in a chart to have a proper understanding of what it is. So when we put it in a chart, this is what we have. So we can see that those that that defaulted for married couples, that's very few, and those that defaulted for single people, also very few. So majority of the people actually did not default. So and this also has a role to play, because I mean we have to be considerate of this, because it will tend to result into bias in our prediction later on. So we have to find a way to handle this, because they are underrepresented rather as well. So here we try to also view the job distribution by doing a value count on job and plotting it on a pie chart. So when we do this, the pie chart comes out, and then we see that the job that dominates the most is the blue collar job. I don't know if this is a coincidence, blue collar and then blue collar. I hope it's not a coincidence. So here is what, okay, I hope the volume should be okay now. Here is the thing we should put into consideration. The blue collar jobs are quite, they dominate the job distribution, the population distribution according to job type. So followed by management, which is something we've seen earlier, but we just decided to put it on a pie chart. However, rule of thumb for visualization, it is not always recommended to use pie chart, except that's the option you are left with, which in this case, yes, this is the option. We can use bar chart, but we have so many bar charts, so let's just have a feel of pie chart and see how it is. Then we can also decide to regroup again. We group by job and education, and then we count by education and see how they are distributed again. So when we do this, we see that those that are in management position, majority of them finished tertiary education or institution, finished tertiary education rather. So then we have another one here. You can still see management appeared again. Those are people who finished secondary school, secondary education. Then the blue collar and then technicians finished secondary education. So if we look at it, we can say that, okay, fundamentally most of these guys that had managerial job or technical jobs or blue collar job finished either tertiary education or secondary education. So we can put this on a chart and then we compare them. So when we do this, we can now see that, okay, tertiary education is the one in blue, and then management happens to be maintain a high for management. Most of the people holding the position in management finish tertiary education, then followed by secondary education. But for blue collar job, most of the people that that has the job finish secondary education followed by primary education. So when we take this further, we can see that majority of the other job types finished secondary education. So where we can see tertiary education again are those that are self-employed. So this is not enough, but this is to help us understand something, which we'll take a look at briefly. So we now try to see again the relationship between age and duration using a joint plot. So when we do that, okay, it's loading. When we do that, it's going to give us a scatter plot, yeah, kind of a scatter plot, but this is a joint plot, where you see how the data points are distributed when you compare duration against age. And here we have outliers, right? We have outliers. Those points are outliers. The rule of thumb is that when you have this guy, any point that is above the 3 times the size of this place, okay, I will not be able to describe it perfectly well, but here is what there's a link in this notebook where you can watch another video I did with Women Who Code, where you understand the difference in outlier, how to detect outliers, how to identify them. So but in this case, this is 2000, the duration is 2000 here. From 2500 can be considered as outlier. That's the middle here. You can consider this as outliers, so you can remove them, but that is not for me to do. I think I set it as an assignment. Yeah, at 2000, that is exercise 3. 2000, enter your code here, filter off duration above 2000. Those are outliers, so it's your job to do that. Then we also check how age, the relationship between age and balance. So we do this, and then what do we have? Okay, it's still loading. So whatever we have there, you are also encouraged to do another assignment, which is to remove the outliers as well. So here we can see that there are also outliers. So for the balance, anything above 3000, I think, yeah, this is the middle here. That's the middle here. So anything above 3000 should be regarded as outliers and dumped. So There are other outliers, but I hope they don't have much impact, like these guys, this below at the tail end. So you are to write the code and filter off 3000 and above. So we only need the ones below 3000. That's for the balance feature. That's your assignment 4. So we go ahead and then we do a count. This count, again, this time around we want to see the relationship between education and then those who subscribe. Do they subscribe? Yes. Do they not subscribe? We want to know. So does it have anything to do with their education? So we group by education and then the status of those who subscribe, and we see that those in secondary school, those that finished secondary school education, most of them did not subscribe. Majority of them. That's like will I say 10% of them subscribe out of 100. So out of 100%, 10% subscribe. So only 90% did not subscribe. Only 10% subscribe. And if we look at the tertiary guys, we also see that almost the same thing applied to them. Those that finished tertiary education will have over 11,000 that did not subscribe, and those that subscribe are just around 2,000. So that's like around 20% of them subscribed. 80% did not subscribe. So, but that's not the case for, I think, is it okay? It's similar case with primary education. So we can represent this on a bar chart, and it's also advisable that your bar chart should be horizontally placed so that they will be pointing to the right. This is also another rule of thumb for data visualization. It's not good to keep them vertical. It's good to keep them horizontal for easy reading. So we can also plot this, and then we see how they are distributed. So based on whether they subscribe or not. Then we do the same thing with job. We want to see how job has a relationship with our target feature. You know, that's what we did with education. So we do the same thing with job, and then we plot the feature. You can see here I did not include comment again because the comment is similar to the comment we have up. So the same code, we are just adopting it for different things. So when we do for job, we see that only those in management had a high percentage of subscribing. Others hardly subscribe when it comes to based on job, not based on education now. So we didn't even see anything concerning these other guys that are not that are non-management level guys. So the other thing here, I will take a look at your questions in the comment section after this description of this notebook. So we can still do the same thing on marital status to see if there's any relationship. Maybe those who are married tends not to be able to pay their debts because they are married, they have more responsibilities. So we take a look at it, and all we had, quite alright, yes. Majority of them did not actually subscribe. So, but then some of them subscribe, and those that subscribe are way more than the single people that subscribe, and of course the divorced people barely subscribe to the service. So we run the same thing, we just tweak it a bit and try to see if we group by job, education, default, those that defaulted, and then the subscription, then count by subscription, is there anything that we'll find that is intriguing? Most likely not really that much, because you can see that those that have managerial jobs and also finished tertiary education, they did not default, most of them did not subscribe. So before you could see someone who subscribed, the person finished management job, tertiary education, did not default, but then they subscribe, but they are very few. That's like around 1,000. So that's less than 10%, will I say, less than 20% rather, of those that did not subscribe. So after taking a look at this, we can decide to say, okay, let's see how month is distributed as well, because maybe there is trend in the pattern based on time. So first we do a pie chart plot of to see how month is represented, and we see that the month of May is mostly represented, followed by June, and then August, and then July and November. So other ones don't count that much. So this forces us to go back again and said, okay, let's see those that subscribe, how did they did they have anything to do with the month? So when we do that, we see that most of the subscription happened in May and August. And then when you come back here, you realize that May and August, I think they are the top. Yeah, the top three. You can see August is here, May is there. So, and you may want to say, okay, you may want to explore further. Does it have anything to do with the marital status? Does it have anything to do with the job type? You may want to explore further how the job correlates with month. If the job has any relationship with month, if the job has any, if the education has any relationship with the month of the year, and of course there are much more things to do in terms of data visualization, so that this will help us to understand how our module will behave, those that are overrepresented, those that are underrepresented, and we'll know how to handle them later on. So your next assignment is to be able to run this code. It is already written. It's a categorical plot comparing month, job, and then using subscription to identify them. So the second one is also the balance against month, and then using subscription to also identify them. Is there any particular month where we have lesser balance, and then is there any other month where we have big balance? Does it have anything to do with the period of the year? So you run these two codes. It's for you to run. You can always tweak it to your taste. And then your last assignment is here, but it's not really much of an assignment. So this notebook, you are going to save it. So you save it, whatever the name of the notebook is. Be mindful that as you are making changes to your assignment, the name of the variable will be changing. So all of this code may not run for you because you have done something along the line. You have to put that into consideration. I think that should be. Let me quickly show you what I'm talking about. Yeah, here. So whatever you do here, you are going to save it in a variable, and then so you have to now pick the name of that variable and adopt it. So maybe when you come down here, you have to now change this guy, this new df, to gdf, so that it can work for you, because you've modified the data. So take note of that. After you've done all that, you are now entitled to come and save your data. So index first, we are not going to include the index. The name of the data frame, that's the name, the last name you could possibly think of. Like in this case, we grouped by this. If we want to save this file, df sub, what we'll do is that we'll come down here, and then we'll come down here, and then we do a save. We do this. It's now df sub.csv. So this is what I'm talking about. But then if we are not doing that, which is not the case with you, because you are going to modify all your data, but then you shouldn't forget the data frame you will be saving. It's not the one that you grouped that you'll be saving. The data frame that you modified last. It's out of that data frame that you modified last that you'll be grouping to visualize. So you are going to save it here, .csv. And of course, expecting you to push it to GitHub. So you can watch a YouTube description of outliers here from Women Who Code. You can also read an article about outlier using box plot diagram to identify outliers, which is something we just described. I think we described that here. Yeah, this is a box plot just to identify outliers, of which we removed these guys, and we are left with this, which has no outlier. So, and you are going to do something like this as well. It's part of your exercise. So let me quickly check YouTube if there's any question, and also to check Slack if there's any question for me. So okay, okay, Oyero Sekinat said she think it should be 30,000. Okay, I don't remember that part, but let me check it quickly. I think that should be around here. Maybe I didn't take a look at the numbers properly. Okay, yes, it's 30,000. Sorry, I took away one of the zeros. I guess I needed money, that's why I took it away. So it's 30,000, not 3,000. So if there's any question, let me know. If you think there's anything that is missing, if you think there's something you want me to redo, please let me know. Let me quickly check. So I will assume that there are no questions for me to handle currently. So feel free to go to Slack and drop your questions, or use the under the video description. You will see where we have to handle where we put a link to our email address. Rather, you can send your questions to the email address. You can post your message on Slack. You can use Slido. We'll definitely attend to you. So our aim is to make this as easy as possible, such that if you understand the basic, you can build a more complex situation out of this. So once again, I will say thank you for your time, and of course, see you next week. If you have any question, let us know. Thank you.